Welcome back. Today we are going to have a little introduction to the central limit theorem before we get started for lesson 6.3. So what we're doing here is we're measuring the length of time in days that a cookie recipe lasted at the Olmsted homestead. So they made a batch of cookies and they recorded how long the batch of cookies lasted before they were all gone. So the first time they made the recipe, they only lasted a day. The second time they made it, they lasted 5 days. They recorded this all the way through 60 days. And on the 60th day, the 60th time that they made the cookies, the batch only lasted 5 days. So this is going to be considered our population. And so the population mean, when I put this data, just the X's into Desmos, was 3.57 days. On average, the batch lasted before they were all gone. Then the standard deviation was 2.148 days. And this is from population data. Okay. Then I had the class do some random samples. So we did 4 random samples, and each of those samples consisted of 5 data points, randomly taken from this data right here. And we looked at those samples. So in those samples, we had the first sample had an average of 2.4 days, an average of 4.2 days, an average of 3.8 days, and then an average of 4. And so when I averaged the averages, these averages averaged to be 3.6 with a standard deviation of 0.816. Okay, notice that the average number of days that the batches lasted still was close to the original population mean of 3.57. Our average of the samples came out to be 3.6. However, the standard deviation is much smaller because these samples should be pretty alike. Even though one is going to have a low number of days, one is going to have a higher, they're not varying from each other very much. Now, I had them take the another set of samples. So we did 4 more samples, but this time in the samples, I took 10 data pieces in each sample. And here's what we've gotten for those samples. $3.5, 3.4, 3.5, and 4.2. We're skipping the histograms. And so when we did that, we can then see that the average of these samples was when n equaled 10, the average of the averages was 3.65, and the standard deviation of the averages was 0.3697. So let's put this all together on here. So we're fairly sure they're going to all be considered normal, but this one was 3.6, and then the standard deviation was 0.816, and then this was 3.65, and standard deviation was 0.3697. And so what we can do is we can think about it like this. We have our population distribution, which we said was normal already. And the population distribution was at 3.57 was the mean. And then we took samples of size 5. And those were a little bit closer together, but still had the same center. And then we took the samples of size 10, and those were even closer together. And so what that shows us is that when we take samples of samples, and the bigger the sample, they're still going to have the center at where the mean was, but they're going to be more and more like each other. They're not going to vary from each other from sample to sample to sample. So in lesson 6.1 and 6.2, we talked about a particular instance occurrence happening. So what is the probability of finding one smartphone user that's younger than 23 years old? Now we're going to be looking at the sample. What is the likelihood of taking a sample of smartphone users and having the average of that sample be younger than 23 years old? And so that's what we're going to look at in lessons 6.3 and 6.4.